We are going to start infinite series now, which is our first unit. Right from the beginning, I will tell each and every concept required for understanding infinite series. So first let us see what is an infinite series. To understand what is an infinite series, first you need to understand what is meant by a sequence. And so we will start from the definition of a sequence. So sequence is any function, it is any function whose domain is set of all natural. Let us make it a point. I'll explain you the things on the right corner there. It is not required for notes. I'll rub it from there, and whatever required for the notes, I'll be keeping here. So after filling the board, I will come there. You take the screenshot. But you need not do. I will take the screenshot, or it is better one of you take the screenshot. We will share it afterwards. So to explain here, I will come. You are saying that it's a function. So you know the minimum details of what is meant by a function. So you have two sets into discussion. One is called domain, this one, and this is called codomain. Domain, codomain. What should be the codomain? It can be anything. But the domain should be set of all natural numbers. Suppose I take 1, 2, 3, 4, so on. I cannot take 2.5 into that. I cannot take negative numbers into that. No fractions, no negative numbers, only natural numbers. All natural numbers I am taking. Let us take some rule. For example, the rule is f of n. F of n is equal to n square. Try to understand the main first starting difference. That is, generally you are familiar with f of x is equal to x square. Instead of x square, f of x is equal to x square, I am saying f of n is equal to n square. There, that x can be any real number. But here we are limited to only natural numbers. So instead of taking x, I am taking it as n. So f of n is equal to n square. What are the values of n it will take? Natural numbers 1, 2, 3, 4, so on. So this is the set of natural numbers. What is the image of 1 as per this rule? 1 square, that is 1. Okay. 2 square, that is 4. 3 square, that is 9. Over this one. If I change the function, for example, there will be different outputs now. Just have a look at another, just a simple example. That is f here. Same f I am using here, there is no problem. Natural number here 1, 2, 3, 4, so on. I am taking the rule as f of n is equal to n by n plus 1. Is this visible there in that one? Okay, good. F of n is equal to n by n plus 1. So what are the outputs as per this rule here? This is set of all real numbers. We are taking all real numbers, then that is called real sequence. What is this here? It's a function whose domain is set of. There is nothing said about codomain. So in the codomain, you can take numbers, real numbers, you can take complex numbers, you can take matrices, you can take functions, so many things. But in your first unit, you are limited only to sequences of real numbers. Sequences of real numbers. So what will be the codomain now? This definition is permitting any codomain. But we are studying in unit 1 only sequences of real numbers. So what is there on the right hand side now? Come on, please tell. No, real number. I mean to say set of real numbers. That is our codomain. So what will be the images now? 1 by 2 for this one. 2 by 3. 3 by 4. Enough. You can understand now. So these are the outputs. This function is a sequence of real numbers. This function is a sequence of real numbers. Now, if you look at these two, let us drop the common things. What are the common things? This ellipse symbol is common. Let us drop. These arrows are common. Let us drop. Again, what is common? Let us drop. Natural numbers. Always natural numbers will come or not? So, what is the special thing coming out of this diagram? Only these numbers. So, as per this rule, what are the numbers coming? 149. Is it beautiful idea to write 149 in this line rather than writing in this vertical way? Let us write it in the horizontal way. So, what is that one now? 1, 4, 9, 16, so on. Over. What is the conclusion of this sequence? 1 by 2, 1 by 2, 2 by 3, so on. Now we call this sequence as some un, for example, un. Actually, this un is short form for u of n. Instead of f, I am using u. Instead of f, I am using u. U of n. Let us go for simpler notation. So I am removing even this brackets, and that n I am pulling down. So it looks like un. Over. So this is nothing but u1. u1. This is the image of 1, and this is the image of 2. So it is u2 comma u3, so on. Let us give the name of this sequence as vn, suppose vn. So what is v2? 2 by 3. What will be v3? 3 by 4, so on. So these are two examples of sequences. Are you clear about the definition? What we are interested in? Only outputs. Inputs are always 1, 2, 3, 4, so on. So this is the sequence, and it is best way to write this sequence in the ordered notation, brackets like this, because position should not be changed. So this is to be written in this way or these brackets, one and this way. So we are using this for ordered notations. I hope you are clear about ordered. Do you know, in the set notation we will write like this. In the ordered pair notation we write like this. Order is important. First 2, then 3. It is like a two-dimensional point. If you write 3 first, 2 next, that meaning will be different. So brackets, if you are using like this, order is important. Better you come here, both of you. You come in the first bench, you go to that bench. Comfortable? Okay, leave it. So this is clear? Now, so instead of writing just the list of numbers, we write these brackets. That is best notation. You drop these brackets, okay, it is accepted. It's okay. So you write like this. You write like this. Now, instead of showing these, I will just simply say that Wn is a sequence. Wn is a sequence. I should just give the rule enough. No need to show the numbers. So let me give the rule. Let Wn is equal to a sequence where Wn is equal to 1 by n. So how will be the terms of this sequence? 1 by 2, next term, second term. 1 by 1, first term. 1 by 1, 1 by 2, 1 by 3. Is this all clear? Are you okay to here? Now, so you understood. So what are the examples? These two are the examples of the sequences. I hope this is not much required, because our main concern is about infinite series. So I will move fast in background. We will start the infinite series. So sequence is clear. Over. Next. Actually, we will record this from the definition of infinite series. So, however, this is over. You got an idea of sequence. Let's see from here onwards. If un is a, let me say here itself very clearly, that is convergent sequence. A sequence is called convergent. A sequence is called, means you are telling that, naming that. What is that called? Convergent sequence if it has limit. We discussed in earlier class some background about it, right? So it is a limit. If there is a limit, that sequence we call it as convergent sequence. If it is not convergent, in all other cases it is called divergent. Divergent categories are diverging to plus infinity, diverging to minus infinity, oscillating finitely, like this only, this much only, finitely, like this. And if the gap increases, going that side, coming this side, the gap increases infinitely, oscillating. That is oscillating infinitely. This is oscillating finitely. Let us not go in much detail of divergent sequences. Clear about convergent sequence? Very nice. Now we will start what is an infinite series. So shall I remove this title? Unnecessarily we are losing the space here. So we will start with infinite series. Very important difference between sequence and series. You try to catch it. That is, if un bracket like this is a, I'll give you time to take the screenshot of that. If un is a sequence, what should come to your mind is, I write just this much, u1 some number, comma, be careful, comma, u2 comma, u3 comma, u4, and that u1 u2 u3 are coming from some background function, that is un is equal to some function, maybe n by n plus 1, maybe 1 by n, maybe something else. So any function that is a sequence. Back to the point, if un is a sequence, then Sn, carefully see, Sn, this bracket is, it's again a sequence, is called better where now question arises very simply, what is this Sn and un relationship? So if un is a sequence, then sequence Sn where Sn is equal to u1 plus u2, so on up to, be careful, I am stopping at un. So what is my S3? No, what is S3? u1 plus u2 plus u3, stop. u10 will be u1 plus u2 is going to be u10. S1 will be just u1. S2 will be u1 plus u2. So this sequence Sn, where Sn is like this, is called infinite series. Is called infinite series. Now just tell me, that is, what is this Sn, you tell me now? u1 plus u2, comma, this is actually our S1, this is our S2, S3 is u1 plus, comma, so on. So this new sequence which we have created from this background sequence, this new sequence is called as infinite series. Okay? I hope you are clear. Shall I move forward? Okay, fine. Very simple point now. That is, instead of writing u1 comma this comma this comma this, it is beautiful idea to write the general term and just give a continuation. That is, here u1 plus u2 plus u3 plus so on. Be careful, I am not giving comma. u1 plus u2 plus u3 so on is short notation for this short notation for infinite series. Okay. Be careful. I will give you one sequence. You have to prepare an infinite series. Simple. I will say un is equal to n by n plus 1. Tell me what is the infinite series for this background sequence. That is sigma un, n is equal to 1 to infinity. This is the shortcut notation for u1 plus u2 plus u3 so on. When you are adding, you will just simply say sigma. Right? Sigma. N is running. Where is that n substituted? Here. So u1, because it is sigma, you write plus u2 plus u3. So this is the shortcut notation for this one. Now this is like sigma n is equal to 1 to infinity. Un I am replacing with n by n plus 1. If I expand this summation, what I get? 1 by 2 plus 2 by 3 plus 3 by 4 and so on. So this is an infinite series and 1 by 2 comma 2 by 3 comma 3 by 4 comma so on. This is the background sequence. So for every infinite series there will be some sequence in the background. It is like it is back end. This is front end. You are very clear about back end and front end. Yes or no? Okay, good. So are you clear up to here that we have a background sequence in the back end and front we have an infinite series. Now comes the most important thing, that is, okay, I'll just move that side. Somebody you take the screenshot. At least one of you you take it. Either you are not taking or you are all taking. Or okay, enough. Leave it. Time is over. You can't take it now. Over. Leave it. So this is nothing but infinite series. Once we say infinite series, is it a sequence or not? Be careful about these two terms. Infinite series is, however, a sequence. That sequence is S1, S2, S3, so on. And this sequence, for example, in this case, how is that sequence of Sn? 1 by 2 comma 1 by 2 plus 2 by 3 comma 1 by 2 plus 2 by 3 plus 3 by 4 comma so on. Okay, fine. Now if this sequence is having limit, this sequence, be careful, this sequence 1 by 2 comma 1 by 2 plus 2 by 3 plus so on, like that, comma. This is again a sequence or not? If this sequence is convergent, then we say this series is convergent. Once again I repeat, if this sequence is having limit, this sequence is called convergent. If this sequence is called convergent, if this sequence is convergent, we will say this series is convergent. Okay? I hope you are all clear. So when this series is convergent, if this sequence, there is a name for this sequence, we call it as sequence of partial sums, because it is just one part, two parts total, three parts total, that is sum of one term, sum of two terms, sum of three terms. So it is a sequence of partial sums. So from a given sequence, if this sequence of partial sums is convergent, then that infinite series we call it as convergent. I hope you are very clear about it. Now I will write one sequence. You tell it is convergent or not. Then we will have the infinite series from that, and we will see is it convergent or not. Then that will be the conclusion of this particular concept. So I am removing this now. It is very important concept, keep in mind. So simple sequence I am writing now. That sequence is un is equal to 1 by n bracket. Means where un is how much? 1 by n. So what are the terms of the sequence you tell me now? Sequence I am talking about un. u1, u1, u2, u3, so on. Three terms are enough to understand what I mean to say here. So what are the terms now? Tell me. 1, 1 by 2, so on. This is the sequence un. If you see the sequence like this, I will call this as 0 on the number line. Very beautiful example to understand the concept of convergence of infinite series. Infinite series. This is number line. I will call this as 0. I will call this as 1. Tell me where is the first term? u1. 1. I will make a star here, right? This one. Next, the second term. This is u1. 1 by 2 is here, roughly. This is u2. This is 1 by 2. Where is the third term? 1 by 3. So it will be here, roughly, u3. So the gap here between first term and second term is different, or here this gap is less. You can just go by common sense, this gap is reducing. Are you able to understand? Yes, this gap is reducing. But it will never cross this 0 because every coming term is 1 by some natural number. Therefore, it will never become negative. It will never become negative. It will not cross this. And this 0 is so special number 1 that all the terms are approaching to 1. And this 1 is the limit of the sequence. Now tell me just simple, is it convergent? Yes, very good, because it is having limit. So this is convergent. What is the limit? Limit is 1. Be careful. I am so sorry. It's approaching to 0. So what is the limit now? Limit is 0. I am so sorry. Got it. Limit is 0. It's approaching here. So 0 is the limit of the sequence. And hence it is convergent. But if you look at the sequence of partial sums, there is a very different situation. So what is Sn now? Sn. 1 by 2, 1 plus, comma, better it is S1. S2 is how much? 1 plus 1 by 2. 1 plus 1 by 2. Just 1 minute. Only 1 minute. So 1 comma, 1 plus 1 by 2 comma, 1 plus 1 by 2 plus 1 by 3, so on. So what is the first term of the sequence? What is the first term of the sequence? 1. Is it falling down? You see, falling down. It's approaching to 0. 0 is the limit of the sequence. But you see here in this case, it's 1. Adding 1 by 2 this one, 1.5. And adding 1 by 3 to this one, 0.33, no? This one. So 1.5 plus 0.33, that is 1.833, so on, 3 bar. Is it growing or not? It's growing. But the point here is, even though it's growing slowly, it's growing very slowly, this gap is reducing, you see. It goes on growing. There is no limit for this sequence. There is no limit for this sequence, comma, comma, this comma, this comma. So 1, now what is the conclusion? 1 plus, madam, 2 minutes. Just 2 minutes, 2 minutes. 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus so on. This is divergent because it has no limit. No limit. Therefore it is, this is, there is no limit. Now normal question comes, normal common reasoning that comes, that is how it is divergent. We will see in the next class how it is divergent. But be careful, exactly similar to this one example here is sequence un is equal to 1 by 2 power n. What are the terms of this sequence? First term 1 by 2, 1 by 4. What is the limit of this sequence? Same 0. It's falling down, no? Finally it is approaching to 0. This is convergent. But when you go for Sn for this one, Sn. So what is Sn for this one? You tell me. 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16, so on. And you will be surprised to know that this series, which is nothing but 0.5 comma 0.5 plus come on, tell me, 0.75, adding this, is it okay? It grows very slowly, but this is also growing slowly. This is divergent. This is how it is convergent, how it is divergent. We'll see in the next class. Let's stop here. Okay.